Joining me now is Dr. William Kearns. He's the president of the International Society for Gerontology and Technology, so Gerontology. Thank you so much for joining us today.
Thank you.
We're talking about some interesting stuff. Obviously, we have an aging population. We like to keep everybody moving as much as possible. You've been doing some studies on motion, but also on that opposite of motion, falls, to see what happens as far as why people do the things they do. Let's talk about your study specifically, because it's kind of an interesting piece. You have a little piece of radar here, a little bit of math, and a whole bunch of other stuff that we're working with. Right. So tell us about the thought behind it.
Well, the idea basically, when we started working in this, was that we were trying to come up with a better way to study wandering in people as they age. And wandering is one of the problems of dementia, and it's a particularly stubborn and dangerous one because people can escape, say, from their homes, and it poses a risk for them to die potentially in adverse events. Out in the community, they might get lost, they might fall, or be struck by a car, or die from exposure. So all of these different types of problems are kind of outcomes, if you will, of wandering. In order to get a better handle on how wandering is related to falling, we set a solution for this that would be technological in nature. Most of the work that had been done previously had been oriented around using graduate students with clipboards who would go into an assisted living facility or a nursing home and gather data. But to do so means that you have to have that person have eyes on the subject at all times, which is a great source of fatigue and the like. So it's very, very difficult for a human being to maintain attention on that one person. Plus, you can only do one person at a time. And the other thing is, when you drop a graduate student in the middle of an assisted living facility, who's going to notice? Everybody. Yeah. So the residents will come up and talk with them, which makes their job, of course, much more difficult. So we wanted to get something that would stay on station at all times, a radar transponder, if you will, that they could wear on their wrist. And this is, in effect, what we came up with. We made use of a technology that was produced in Cambridge, England, by a company called Ubisense. And this product is used routinely in factories to control industrial control systems, like BMW, for example, uses it, Caterpillar, Aston Martin, and Airbus and the like, for their assembly of their large aircraft. So this type of technology is very, very precise. It gives us accuracy of tracking down to about 6 inches inside of an assisted living facility. Now, what do you do with that precision? Think of it like a GPS. And instead of having satellites in orbit, we have satellites inside the building. That gives me very, very precise location of up to a few hundred people simultaneously. Now, you talk about big data, you get loads and loads of information. For example, in a study of 53 people that we use this technology on, we followed them for a period of a year and generated about 43 million records on these folks. And from that information, which gave us X and Y coordinates within the location of a three-dimensional space, we applied fractal mathematics to this. It sounds like a really tough concept, but it really isn't. This particular measure, called fractal D, varies along a continuum of 1 for a lower value to 2 at the upper value. A 1 is basically a perfectly straight line, and a 2 is a drunkard's walk. The person is moving back and forth so radically that they're almost guaranteed to fall down. Turns out everyone's path as they move through space can be described as either a straight line or some point along that continuum. And it turns out, for most normal people, that's about a value of 1.27 and below. When you start getting above that, you start seeing cognitive problems. We have found, for example, that the higher the value in the fractal dimension number, the more likely the person is to have dementia. They're also much more likely to fall. In fact, so much more likely that we can actually predict in advance when they're likely to fall. That's critical because it means now we can go to that person specifically out of a group of 100, say he's having problems, and then apply some kind of a therapeutic measure. Maybe that person has an infection that hasn't been diagnosed. Maybe they haven't been eating well, they haven't been sleeping well because there's been too much noise in the facility, or some other problem that needs to be addressed by medical personnel. So what we want to do in the end is have a product that allows assisted living facility operators to really tailor their resources and use them much more efficiently and much more effectively to meet the needs of the residents of the assisted living facility. If we can do that, we can save them money. We can also reduce the liability, the chances that people are going to fall, because these falls are very expensive. People who have falls, typically you see out-of-court settlements of $150,000 to $200,000 per. If we can start reducing those in assisted living, that will translate to a savings for them, an improvement in health care for the individuals being affected, and overall benefits for everyone.
Sure. Now, when you look at falls, it's just not a cost issue. Also, we know that the statistics show that if someone falls and they're in advanced age, that their life expectancy actually goes down. So
Yes,
you're going to
that's
actually
true.
be saving people's lives by making sure they don't fall. And I
Right.
think the other thing you mentioned was that you can watch over time. So if someone's walking and they start changing their walk, you'd be
Right.
able to pick that up in this data.
That is true, and we've seen that in a number of cases where individuals' fractal dimension values from one day to the next show a gradual increase over time, and this increase in the slope is terminated by a fall. And interestingly enough, afterwards we do see them walk a little bit more carefully, and they tend to be a little less extreme in terms of their values on fractal dimension, but it creeps back up again. And in cases where we've also done parallel studies like this in not assisted living, but in persons with traumatic brain injury, we've actually seen the reverse happen. They come in walking more like drunks when they are admitted to the facility, yet as their brains heal, they walk straighter, and we've actually seen these curves. And that tends to co-vary with the clinical estimations of the clinicians before they decide that it's time to let them go home. So that's very significant, because in traumatic brain injury, there are no standardized methods for assessing the improvement of a person after an injury. To the extent that walking and how straight a person walks can be an index of that, that's a relatively easy measure to get. And especially with a technology like what we're talking about, which has already been implemented and tested in rigorous environmental conditions in industrial settings for many years, and has been perfected to that degree. But in this case is coupled only with a piece of software, and as a result, this innovation, which is really not an invention but more of an innovation and improvement on something we already have, can have far-reaching benefits in an entirely unrelated field to manufacturing, namely healthcare.
And a lot of the stuff that we have, we just don't have the technology in place, so it's nice to see that transition over. Obviously, lots of data, so you'll be able to play with this. You're one of the lead investigators, or the lead investigator on this process, so we look forward to seeing more of it. Obviously, it's a small niche now, ALF, but you see this expanding into other areas, so it sounds like it's an exciting process for us. Plus, it's not just watching someone walk, it's really making sure that those individuals are walking the right way so that we don't have the increase in falls and then the decrease in life expectancy. Thanks for the data today. Thanks for the information. Great information on that part too. I can't wait to see the final pieces. I know you're presenting this pretty soon as well, so thanks for sharing your time with us today. We look forward to seeing more of that.
And this is all taking place over at the International Society for Gerontechnology in the Bayfront, the Hilton Bayfront in St. Petersburg.
Well, look forward to seeing it.
Thank you very much.